Lesson 0.3, Evaluating, Simplifying, and Solving. Oh my! In this lesson, we will be evaluating expressions, we will be simplifying by adding, subtracting, and multiplying polynomials. Division will be left for a later lesson, and we will be solving simple equations in one variable. Before we get started, I want you to think about what is the difference between the word evaluate and the word solve. One of my biggest pet peeves as a math instructor is when students mix up these two particular words, when I ask you to evaluate versus when I ask you to solve, because they cannot be used synonymously. They have two completely different meanings and are used in two completely different contexts. So take a moment, think to yourself, when I ask you to evaluate, what am I asking you to do? When I ask you to solve, what am I asking you to do? As you're thinking about it, here are two mathematical statements. One of these can be used to evaluate, and one can be used to solve. Which one is which? Hopefully you correctly identified this one is one that could be evaluated, and this one is one that could be solved. Because you evaluate an expression, you solve an equation. An equation has to have an equal sign. You cannot evaluate an equation, you solve an equation. You cannot solve an expression, you evaluate an expression. Evaluate has the word value built into it. When I ask you to evaluate, I'm asking you to take a value, plug it in, and get an output value. When I ask you to solve, I'm asking what input can produce a specified output. In this case, 2x plus 1 equals 10. 10 would be the output. I'm asking, what could I plug in for x to get out 10? That's solving. Now to throw a curveball into the mix, simplify. The word simplify can actually be used in several different contexts. You can simplify an equation and you can simplify an expression. Here we have an equation and an expression, both of which could be simplified in the same way, simply by rewriting what we have in an equivalent form. So to summarize, evaluate means plugging in a known input value. Solving means finding an unknown input value. And simplify simply means rewriting in an equivalent form. Let us commit ourselves from this day to the end of days to not misuse any of these words and to use them in the proper context. So our goal in this lesson will be to look at problems involving evaluating, solving, and simplifying. Let's get started. So we're going to start by focusing on evaluating. Now, anytime you are evaluating, you're simply following the order of operations to simplify the expression. Notice how I use simplifying as part of evaluating because they are inherently entwined as one major concept. And we're going to address order of operations by looking at this second of my many pet peeves, this stupid internet meme that keeps going around that people keep posting the wrong answer for, thinking that they're oh so smart. Feel free to take 10 seconds and evaluate this expression. All right, hopefully you have an answer right now, and hopefully it is the correct answer. And you would have gotten the correct answer simply by following the order of operations. Now, there's often a misunderstanding of what the order of operations actually means. So PEMDAS, as many of us know it as, or parentheses, exponents, multiplication, division, addition, subtraction, is the order in which operations should be applied. But it is not a 6-step process, it is a 4-step process. Parentheses should be done first. Anything inside parentheses should be simplified. Exponents should be done next. Anything where there's an exponent, apply the exponent. Step 3 is not multiplication. It is multiplication and division. Multiplication and division are not two separate operations. They are the same operation. They are simply two sides of the same coin, just like addition and subtraction are the same operation. Subtraction is just adding a negative number. Division is multiplying by a fraction. Do not think of PEMDAS this way, but this way. Parentheses, exponents, multiplication, division from left to right, addition, subtraction from left to right. Because if I have multiple of the same operation, the rule of order of operation says approach it from left to right. So in this case, parentheses first would require me to do 1 plus 2, which is of course 3. There are no exponents, so I skip over that, and then multiplication division. So it says 6 divided by 2 times 3. I don't start with 2 times 3 because that's multiplication and then do the division. No, I do multiplication division from left to right. So 6 divided by 2 is 3, and 3 times 3 is 9. The correct answer is 9. If you don't believe me, feel free to type this statement into any random calculator that supports order of operations, and it will tell you 9 because it's going to do the division before the multiplication. So the next time your Aunt Karen sends this to you on the face page, feel free to tell her to go back to 6th grade. So with that in mind, let's look at some actual algebra level problems. And you should be able to handle all of these on your own without much guidance from me. So I'm going to go ahead and let you try all 5 of these on your own, and then you can hit play when you're ready. Keeping in mind, it says no calculator. If you had a calculator out just to check your work on the last problem, go ahead and put that away because you will not be using it in the rest of this lesson. It is crucial to be able to do everything we do in this class with a calculator as well as without a calculator. If you can't handle doing it without a calculator, you don't deserve to use the calculator. You can't win a race if you're always running on crutches. Don't grab a calculator because you don't know how to do it otherwise. Grab a calculator because you know how to do it, you trust yourself, you believe in yourself, but you've got other things to do today. My general rule of thumb is that I only ever use a calculator because I'm lazy, not because I'm not capable. So proceed with these 5, but without a calculator. So starting with question A, C minus D minus A to the 4th, replacing each letter with its appropriate value. C, which is 4, minus D, which is negative 5, minus A, which is 2, raised to the 4th. Now you'll notice I used parentheses every time I substituted a value. Technically, you should 100% of the time use parentheses anytime you're replacing something with something else. Anytime you're using substitution, you should be using parentheses. Often we don't use parentheses because in many cases, those parentheses don't make a difference, but sometimes they do. Rule of thumb, if you don't know when or when not to use parentheses, then just use parentheses. It's hard to overdo the use of parentheses, but it's very easy to underdo it. Removing a set of parentheses can often completely change the meaning of a problem. If you don't know when or when not to use them, then use them. If it involves a negative number, use parentheses. Definitely use parentheses on negative numbers. As we move forward, you'll see why I say that rule specifically. So following the order of operations, keep in mind parentheses first really means simplifying what's inside the parentheses. I've got a 4, I've got a negative 5, I've got a 2. There's nothing inside the parentheses that can be simplified. So moving on to exponents, I've got 2 to the 4th, which is going to be 16. Now I also went ahead and took care of this double negative right here. Since I have a double negative, I replace it with a positive. And now there's no multiplication division. I'm just going to do addition, subtraction from left to right technically, but as long as you keep the 4 as a positive, the 5 as a positive, and the 16 as a negative, you can actually add and subtract in any order. It's just rule of thumb, if you don't know where to start, go from left to right. In this case, I'm going to combine the 4 and the 5, which gives us 9. 9 minus 16 gives us negative 7. Final answer. All right, and here's where the parentheses are really going to start to matter because of all the negatives. If I replace A, B, C, and D with their appropriate values, I get this statement right here. Notice this negative right here, this negative right here, this negative right here is outside the parentheses because I replaced A with the 2 inside parentheses. What's being squared is A. I am not squaring the negative. I am squaring the A. I am not squaring the negative. I am squaring the 2. I am not squaring the negative. This does not say negative 2 squared because it says A squared and A is 2. A is not negative 2. B is indeed negative 3. I'm going to cube the negative 3, but the negative that was on the outside has nothing to do with the negative 3. So as I go to simplify this, I'm going to evaluate all of the exponents. 2 is being squared, that's going to make that a 4, but I'm not squaring the negative, I'm only squaring the 2. So the negative is still going to be there when I'm done squaring. Notice here, negative 3 cubed, negative 3 times negative 3 times negative 3 is negative 27. So the negative is still there on this cubing operation, but there was also another negative because of the subtraction. So I technically have 4 negatives there, which makes it a positive 27. I then have minus 16, and then plus 125, because negative 5 cubed is negative 125, which is being subtracted, which makes it positive 125. These negatives raised to powers can be tricky for the uninitiated, so make sure, until you're more comfortable with it, make sure that you're using parentheses to signify whether the negative is inside or outside on the parentheses. So now let's combine like terms. Again, I can work this from left to right, or I can realize that addition and subtraction can be done in any order as long as the positives and negatives of the numbers are maintained. So what I'm going to do is I'm going to take the negative 4 and the negative 16, combine that to be negative 20. I'm going to take the positive 27 and the positive 125. I'm going to combine those to be 152. And then I'm going to take 152 and I'm going to subtract 20 to get 132. Final answer. All right, here's question C. I'm going to take the A and replace it with 2. Notice I didn't put the 2 in parentheses because I thought to myself a few steps ahead and realized that the parentheses around the 2 weren't going to make any bit of difference, so I went ahead and didn't bother putting the parentheses. So now order of operations, we'll start with 2 minus 5, which is negative 3. The negative 3 is being squared, making it a positive 9. 9 times 2 is 18. 18 and 1 is 19. Final answer. All right, next question, 4 minus 3 times b plus 1 cubed. Common mistake on this one is to start with the 4 minus 3 and get 1, which of course makes no sense because the order of operations says subtraction is one of the last things that you should be doing. First step is we'll take b and replace it with negative 3. Again, I didn't use the parentheses because they weren't going to make a difference on this problem. Negative 3 plus 1 is negative 2. Negative 2 cubed is negative 8. Negative 8 and negative 3 is positive 24. 24 and 4 is 28. Final answer. And one more, hopefully you didn't find it too challenging. Replacing A, B, C, and D with their appropriate values. Notice in this case I did use the parentheses when I did the substitution in order to avoid any possibilities for confusion. Once again, the negative in front of the a squared is not part of the squaring operation. It does not say negative a squared. It says negative a squared. The square applies to the a, it does not apply to the negative. So 2 squared gives me 4, negative is still there. Negative negative 3 makes it a positive 3. In this case, the d value is indeed negative 5. Negative 5 squared is positive 25 minus 16. Continue simplifying. On top, I'm going to have negative 1. On bottom, I'm going to have 9. And finally, take the square root of negative 1/9. First off, anytime we have a negative number underneath a radical, hopefully you remember from Algebra 2, square root of a negative means I. So the square root of the top would be I, and the square root of the bottom would be 3. Final answer. So there's your quick review of evaluating expressions. Before we move on to solving, I want to take a side step into simplifying. So here are 3 expressions I would like you to simplify. Pause here, play when you're ready. All right, taking a look at the first one. This one's pretty straightforward. We're just going to distribute. 4 onto n squared minus n gives you 4n squared minus 4n. And then we're going to treat that as a negative 8 onto negative n minus n squared would give us positive 8n plus 8n squared. Now combine like terms. I've got my quadratic term 8n squared and my other quadratic term 4n squared. So that's going to be 12n squared. And then combining negative 4n and 8n gives me positive 4n. Final answer. Here we have one that's slightly more complex because we have the negative 2 minus x being squared before we can distribute. We have to perform the exponent before we perform the multiplication. You can't distribute something that's being raised to a power. Order of operations. Keep in mind, negative 2 minus x squared really means negative 2 minus x, negative 2 minus x. So if I wanted to do this the longest possible way, yes, there is a shortcut to this, but you have to earn it. I would simply rewrite the square as 2 separate groups of parentheses and then distribute it out. So if you multiply through on that negative 2 minus x times negative 2 minus x, you'll end up getting 4 plus 4x plus x squared. Everything else comes down for the ride until we're ready for it. But as I said, yes, there is a shortcut. Recall, from our previous lesson on factoring, we talked about factoring perfect square trinomials. When something's of the form a squared plus 2ab plus b squared, it factors into a plus b times a plus b, or a plus b squared. I could also say this the other way around, a plus b squared. If I multiply this out, a plus b times a plus b, I will always get a squared plus 2ab plus b squared. So with that in mind, anytime I'm multiplying out a plus b squared, I could simply go straight to the answer of a squared, b squared, and 2ab in the middle. So for instance, when I have negative 2 minus x squared, if I remember this little rule, I can simply square the first term and get 4, square the last term and get positive x squared, and then the middle term will always be 2 times a times b. In other words, multiply a and b together, negative 2 and negative x would be positive 2x, and double it to make positive 4x. So going forward, anytime you see the expression something plus or minus something squared, you could just square the first term, square the last term, and then multiply the two terms together and double it for a quick multiplication of a squared binomial. From here, we'll distribute, and I get negative 20 minus 20x minus 5x squared plus 12x squared minus 6x. Combine like terms, and writing them in descending order because why not? It's how we typically write it. I end up with negative 7x squared minus 26x minus 20, final answer. One more. Notice once again, a minus 5 squared, I have to do the square before I distribute the 2. And because I now know that shortcut, I can go straight to the answer, square the first term, square the last term, multiply them together and double, quick and easy squaring of a binomial. Distribute the 2, add 1, final answer. All right, let's move on to solving. Now, I would assume that you know how to solve a simple linear equation. That shouldn't be beyond your capability at this level, but I wanted to make sure I threw one in with fractions just to make sure that we're as confident with the easy problems as we are with the even easier problems. Looking at the first one, hopefully your first thought is to subtract 5, and then normally we would divide by the number in front of the variable. Hey, we just had a lesson about dividing fractions, and we know we don't divide fractions, we multiply by the reciprocal. So let's multiply both sides by the reciprocal. The 7's cancel, the 2's cancel, we're left with y equals, and on the right side, 7 times 7 halves would just be 49 halves. Final answer. But I always like to point out on these problems involving fractions, if you don't want to deal with the fraction, then don't deal with the fraction. Simply clear the fraction, just like we did with dividing fractions in that Fun with Fractions lesson. Anytime you want to get rid of a fraction, just multiply everything by the common denominator. In this case, the common denominator would be 7. If I multiply the entire problem by 7, that would become 2y right here plus 35 equals whatever 12 times 7 is. And remember, we're not using a calculator. 12 times 7, you might be thinking to yourself, ugh, I don't want to have to pull out pencil and paper to do scratch work on 12 times 7. Well, let me tell you how I think of 12 times 7. I don't think of 12 times 7 as 12 times 7. I recognize that 12 is actually 10 plus 2. So when I'm doing 12 times 7 in my head, I'm actually doing 10 times 7 and 2 times 7, because of course 10 times 7 is 70, 2 times 7 is 14, and then put it back together, it's 84. Anytime I'm multiplying larger numbers, I'm always going to break them into smaller problems and then add it all together, simply using the distributive property. So 12 times 7 is 84. By multiplying the whole thing by 7, that got rid of the fractions, and then I could solve from here. Subtract 35, I get 49. And of course, the easy way to do 84 minus 35 in your head is I'm going to subtract 5 first. 84 minus 5 would be 79, and then 79 minus 30, well, 70 minus 30 would be 40, so 79 minus 30 would be 49. And then divide by 2, and I get 49 over 2, which is the same answer I got before, and I would probably argue that the way we did it earlier was actually quicker and easier. It was quicker and easier to deal with the fraction instead of trying to avoid the fraction. But if you want to avoid the fraction, it's still a relatively easy problem. Looking at the next one. We could multiply the whole thing by 7 if you wanted to, but again, I think it's easier just to go for it. Add 9 to both sides, and then multiply both sides by negative 7 over 2. It's going to get rid of the fraction on the right, and on the left, notice the 2's will just cancel out, leaving negative 7. Final answer. All right, here are some slightly more complex problems, but just as easy as the previous ones. Try these on your own. My suggestion is to simplify first before you attempt to solve. Pause here, play when you're ready. All right, so let's start with the distribution. distributing the 3 and the 5 is going to give me this statement, 3x minus 6 minus 4x equals 5x minus 15. On the left side, I'm going to go ahead and combine like terms, 3x minus 4x to give me negative x. And then we can start moving terms back and forth. I always like to start with the variable, and specifically whichever one is smaller. Negative 1 is a smaller number than 5. So I'm going to add x to both sides. That gives me 6x. And then let's get the variable by itself by adding 15. I get 9 on the left, and then divide by 6, simplifying into 3 over 2. On this one, just in case you were a little confused by the brackets and parentheses are the same thing. They imply the same operation. They're just grouping symbols. It's just common not to put parentheses inside of other parentheses because it makes it harder to read. So anytime you see brackets, treat it just like a parenthesis. I'm going to start by simplifying, and I'm going to start by simplifying the innermost portion of the problem. That would mean simplifying this 3 times m minus 5 first. Then within that bracket area, I can combine like terms, and I get negative 2m minus 15. Then we'll go one step out, and I see that negative 4 right on the outside. Distributing negative 4 gives me positive 8m plus 60. I can then combine like terms into 8m plus 68. From here, again, I like to start with the variable, specifically whichever one's smaller. So I'll subtract 4m, and I get negative 8 equals 4m plus 68. I'll then get the variable by itself by subtracting 68. Negative 8 and negative 68, keep in mind since it's subtraction of a negative, you can think of it as addition. 8 plus 68. I'm going to think of 68 as 60 plus 8. So it's really 60 plus 8 plus 8. 8 and 8 is 16. So it's really 60 plus 16, which would be 76. So negative 76 equals 4m, and then we're going to divide by 4. Again, we've got a relatively large number. No calculator permitted. You should not be grabbing a calculator for such a simple problem. Just think of it in a different way. 76 divided by 4 is really 80 minus 4 over 4. In other words, I thought of a number close to 76, which I knew was divisible by 4, and I knew was easy to divide by 4. So I broke 76 into 80 minus 4. I can then divide each of those separately. I get 20 minus 1, which is 19. And since it was negative to begin with, I can just say m is negative 19. All right, here are 2 more for you to try. Pause here, play when you're ready. Now this first one on the left, hopefully you thought was a bit familiar because, hey, we already did this problem. 2 times a minus 5 squared plus 1, we simplified into this expression right here. So if you wanted to, you could actually take that whole piece that we did earlier, ending with 2a squared minus 28 plus 51, and just set that equal to 9. In other words, you can solve an equation by simplifying it first and then continuing on to solve. But the problem is, if we do that, that actually makes this problem more complex and more difficult because we're still not even ready to solve. We're going to be talking about solving quadratics in our next lesson, but hopefully you still remember from last year that this is not solvable until it's set equal to 0. So we still are not even ready to start solving this problem. On the other hand, we could more easily approach this problem simply by isolating the variable, just like we did in all of the 4 previous problems. Just because it's a square doesn't mean that we have to use complex techniques. Let's get the variable by itself. The first thing I'm going to get rid of is the 1 by subtracting, and then divide by 2, and then take a square root. Keep in mind, anytime you take a square root, there are 2 possible answers. In this case, positive 2 and negative 2. Because there are 2 possible answers, I'm going to break this into 2 separate problems. A minus 5 equals positive 2. A minus 5 equals negative 2. Add 5 to get the a by itself. I'm going to get 7 and 3. Now, had I continued the previous technique to its ultimate conclusion, I would have eventually gotten 7 and 3 as my answers. But notice how quick and straightforward this method was to get my 2 answers. Yet with this method, I would have still had at least 3 to 4 more steps before I ever got to my answer. If it's possible to isolate the variable, then isolate the variable. That's always going to be the quickest, easiest way to an answer. So go ahead and give the last question a try. Pause here, play when you're ready. All right, so we're going to start with what's on the outside. We're going to subtract the 4 from both sides. That gives us negative 24 on the right side. And keep in mind, it still says negative 3 over here. Divide both sides by negative 3. We're going to get b plus 1 cubed equals 8. Take the cube root. Keep in mind with odd roots, there's only one answer at a time, unlike with even roots. So the answer would be b plus 1 equals positive 2 only, not plus or minus. Subtract 1, we get b equals 1 as our one and only answer.